Am I audible to all?
Yes, you are.
Yes,
Vishnu.
Yeah. Okay. So last session, if I remember, we had seen different types of performance test. So can someone call out which all tests we saw last week when we closed? What are
load
the different
test,
types? Yeah.
stress test,
Okay.
endurance test,
Load test, stress test,
endurance test,
endurance, and
Spike
spike
test.
test.
yes, spike test. Exactly. And there are some other tests, as I said before, also like volume test, soak test, and all, but they are not that common or generally done. Volume test is nothing but where you send heavy volume of data and see how your system is responding for that volume of data. Okay. And soak test is more similar to stress test, but you like increase usage that you try to see like how your system is responding at under heavy load, right? Not normal load but heavy load. So similar to stress test, we call it soak test and all. So yeah, but ultimately for these are the four important tests generally we will consider in most of the test plans. Okay. Like whenever we are giving any proposals and all, these are the most important ones which we give. Now today we will be seeing on some important concepts, okay, like which is mainly required for you to understand any system when you are before you test. Okay, so because if you don't understand the system, you won't be able to know where you are, what you are looking into, where the problems will be, what are the different bottlenecks that you will come across and all, right? And that's one thing. Second thing is you need to know these terminologies, because when someone uses it, you need to know, okay, yeah, this is the thing, okay, or because every component has a significance when it comes to performance. Okay, so out of that, one some important things we will discuss today. Okay, out of that, let's start with the architecture. Okay, so see, when we started the software design, okay, or when the software industry overall started, we had initially one tier architecture, two, three, and then it became more sort of a distributed systems, or we can say our new generation systems, which is more than three tier. So what is this one, two, and three, right? Like we need to understand that. So see, one tier architecture means simple. Okay, like assume like you have okay, you just file was, so that was one architecture where the file was accessible very where client and one customer. Okay, so that is where the one tier architecture came to. Now, let me give you some.
Sorry to interrupt, Vishnu.
So,
It's your voice is breaking. Is that only for me or?
Yes,
Yeah,
yes.
is
yes,
it
yes,
for,
it's tracking. Yeah.
oh, this is breaking. Okay, just a moment. Is it better now or
No, Vishnu, it's same.
No, it is.
okay? Is it
Hello?
yeah? Just a minute. I'm just
Oh,
changing
sorry.
my.
Okay, okay, sorry.
Yeah, no, it's the same. Is it no difference?
Uh,
In
can
my
you speak?
network.
Okay, yeah.
Is it better now?
Yes, yes, yeah.
Okay, okay, yeah, that's
Yeah,
good.
thank you.
In our location, there is a power failure, a major power failure in Hinjewadi, Pune. So where I am now currently. So that's why just I am trying to use my mobile data for today. So
Okay.
could be a reason. Yeah. Anyways, yeah, who are in Pune, they might be knowing. Anyways, because it's a very big issue. Like it has been like 2 days, the power is off from past. Okay, right. So let's get started. Um, so if I just call out some single tier architecture examples, okay. Now, what basically a single tier architecture is simple like a software architecture, right? Like let's say you're using a Microsoft Excel, or if you're using, so there is no network or server communication generally. It's like a software you're using, right? There's no server like communication. But when we moved on to 2 and 3 tier, right? What happened is we have a client handling the presentation and the business logic, server handles the data storage. So it's more sort of now. So generally they divide it into like there is something called presentation and business logic. We call, you can just say like front end and some logical operation, the back end. Okay, and then there is a data, right? These three actually will lead to some good application, right? So in 2 tier applications, what happened was this data was on a server somewhere remote. Okay, this too was on my machine, client machine. So this was 2 tier, 1 and 2. So this became 2 tier, right? Now what happened in 3 tier? Let's say, okay, let me give you an example of 2 tier. Okay, so a client server application with a DB, right? Any client server application with a DB, it was a 2 tier architecture. Okay, now when the 3 tier came, what happened was in the 3 tier architecture, the presentation layer, the UI, okay, the business logic layer, application server, and the data layer, the database server. So this is a little bit of the modern architecture, right, where the UI is handled by your browser, right, which is on your system. App server and DB server will be somewhere in the remote server locations from where we access, right? So this type of 1, 2, 3 is called 3 tier architecture. Now coming to the new generation concept of distributed systems. So what happens in distributed systems is we further divide our application into small units, which in turn might be a 3 tier or 4 tier, whatever, 3 tier architectures, and this all will communicate together to make an application. So such a system was called distributed systems. For example, we will see this in detail when we go to Kubernetes, because Kubernetes is actually a distributed system. Okay, so in what happens is, like, let's say this is accounts and this is order, this is okay, this is login, okay, not accounts, login, logout, order, then cart. So what I'm doing, all the login related stuff I'm keeping at one. Everything is individual. So in this way, when I build a system, we call it a distributed system. Okay, just in a very vague way or like very high level way. Okay, you will see that like in this concepts only, this microservices and all will come. Okay, what are microservices and all? We will see that. Okay, when we move on to the Kubernetes cluster. So this is the final distributed system which we are now in the current generation. Right. So now these are the various types of architectures that we have. Okay. Now these architectures, when I say server, okay, there are two things. The system in which the server is running, the CPU. Okay. When I say CPU, it is CPU and RAM. Okay. So I can say an instance. Okay. Or a node, or a yeah, you can say a system. Okay. Multiple words you can use, different, but all constitute to this, a CPU RAM combination, okay, a system. And the server will have also a software that is running on the system. These two together is actually we call the server generally. Okay. So when I say an app server, so what the app server will have, there will be one when I say app server or a web server, there will be one software that is running on a system. So what software? The web server software, like Nginx is there, Apache Tomcat is there. There are various web server softwares, okay, which we run on a system, on a CPU. Okay. So let's say Apache Tomcat is a web server, okay, software. Now, can a software run just like, I mean, like for running the software, you need what? Where will you run the software?
So server.
Yes, correct. On the CPU in which I am running. So this together we call it a web server. Okay. So when I say web server, okay, now the main question is why I need a web server? Can't I run my application directly in a CPU? Why do I need a web server? So the requirement of web server is simple. Okay. Let's say I have an Excel application in my system. Okay. So same like Excel, I can create my Amazon.com also. I mean like the Amazon application. But what will be the difference in both? What will be the difference?
Standalone.
Exactly. Excel is being used by a single person, right? Now we have this shared and all, but still that is also when you do it online, right? I mean, like when you're running Excel online, not maybe the software, but that also is basically cloud shared only. Okay, so what I'm ultimately saying is now just consider the Excel which we had few years back. Okay, so we had a single person using it, right? No sharing and all, but Amazon multiple people are using at the same time that same application. When such a situation comes, you need between your operating system and the world, you need a server to serve. So, because the other problem here is now in the Excel and your communication, is a third person involved? Anyone? Like anyone from internet is able to use your Excel unless you don't provide any. Is he able to do that?
No.
No, right? But in Amazon, they will, right? This CPU in which the Amazon is running, everyone will be entering, right? So it has to be safe. When everyone is entering, they will enter through the server and then enter the application layer where the application code and everything is there. So the server is the component that will keep the connections or the number of instances or number of threads, right? Or everything. It will manage those things. So server software is for that, serving your application to the world, right? So that's a web server. Okay. So there are different types of web servers like Apache Tomcat and all, as I said. Now, see, based on where you are now, I said okay, there is a server. Now that server needs a CPU to run, right? Now the CPU can be either on cloud or on premise. Now, can someone say what is the meaning of on cloud and on premise? Anyone? Any guess?
Cloud is nothing but it's an Azure or AWS which is operated by some other third party
Yes.
infrastructure, and
Mm-hmm.
on
Okay.
premises is nothing but it is operated in the in premises data
Hmm.
center.
Yeah, you can say that. On premise is more sort of it's in your location. So let me explain you now this very beautifully. So let's say I have my home. Okay, it's my home, and I am running Amazon.com on one CPU. I mean, like one system. Okay, one system which is at my home. Okay, I'm running Amazon.com there, or not Amazon.com. Let's say Vishnu.com. I'm running there. Can I do that? Can I run a website from my home? Okay, let me put it this way. Can I run a website from my laptop? On my
Yeah, you
laptop?
can.
Yes, I can, right? Only thing I need to do is I need to install a web server in my laptop, run it, and in that web server, put my application code, the HTML, CSS, whatever code I have created for the website, right? Put that, and then open the Wi-Fi connection or the IP to the world. So the world will be able to access the web server, and from web server my application. So on my laptop, I can put a website. I mean, like I can run a website. Okay. So this thing, what I'm doing here is called on-premise because it is at my home. Okay. The same thing when it comes to a business, it will be at a location, on their own location, which is managed by them. The CPU is managed, the network is managed, the power is managed by them, and that's the meaning of on-premise. So let's say if I'm Amazon, so Amazon will buy, let's say, 10 some 5 acres of land, and they will build a building. In that building, they will keep like some 500 CPUs to run their Amazon.com. So they will take the Wi-Fi connection, they will take the power connection, and all those that is required, the backup and security systems and all those. Okay, they will set it up, and then they will run Amazon.com from here. This is called on-premise because Amazon, this whole thing is owned by Amazon. They are investing in that. They are buying that. Okay. Now the same thing. Let's say what I do. Let's say I'm AWS. Okay. What AWS will do? AWS will buy a land again. They will buy like 10,000 CPUs. They will take the Wi-Fi, power, and all. They will manage all the things of this. Okay. But only difference will be these CPUs. They will give it to different businesses to use, and these businesses will pay AWS for this managing what they are doing. This the number of CPUs that they are using, right? For example, let's say I'm a business and I need 5 CPUs. I can take that 5 CPUs from this 10,000 and I can pay that amount to AWS. And this structure is called what?
Cloud,
What is
cloud
this?
Cloud.
infrastructure.
Yes, exactly. Right? This is cloud. So if you see, there is nothing great about cloud, right? It is also in a way an on-premise system only, but it is on someone else's premise. Are you getting all of you? So cloud is nothing like it is lying somewhere in the clouds, right? So it's also a simple on-premise system, but it is lying on someone else's premise, which is on AWS. Clear all of you till now? Any doubts? Anyone? Any doubts? Okay. Now let me ask you this question. Okay, when you
Yes.
choose between on-premise
Sir,
and
I have a
cloud,
question.
sure, go ahead.
Sir, I have a doubt in app server and web server. Web server,
Hmm.
I came to know, but
Okay.
what is app server?
Exactly. Okay. So that's a very, very simple query. Okay. Let me explain you. So app server and web server. Now from the name itself, uh, can you guess whether a website will have an app server? Can you guess? Any guess like from the name? Okay. Okay. Let's take this way. Can an like web server will be there on the application, like I mean like the mobile apps and all, or it will be there in the websites, the app server? Okay, simple. Okay, let me explain you this way. So web server and app server. What is the difference between HTML and let's say PHP or Python? Anyone? What's the difference?
Programming language.
Hmm. So basically, this will be serving all the static content, right? Nothing dynamic will happen in HTML. Can you do 1+1 in HTML? Can you do?
No.
Anyone? We cannot. But can we do 1+1 in PHP? Yes. In Python? Yes. So here it is a dynamic content. So anything dynamic is happening on the app server, anything static is happening on the web server. Okay, like for example, serving HTML, CSS, JavaScript, all this is done by web server. And serving like, for example, database access, database operations, processing the logic, running the PHP code or the Python code, all is done by the app server. Clear? Till here? So examples of a web server are, as I call out, Apache, Tomcat, Nginx. Okay, so I'll just name Apache, Tomcat, Nginx. Now, and similarly, application server also we have Tomcat, JBoss is there. Then there is WebLogic, Django, Express.js. These are some of those backend engines. Okay, but one thing is there. Okay, can web server and app server be same?
No.
So there is one example I said, no? In this both I wrote Tomcat, right? Here also Tomcat is there, here also Tomcat is there. So can web server and app server be same? I mean, like, can they deliver both? Any guess?
Web server can be made as app server.
Exactly, right? Yes, both web server and application server can be the same. Okay, like for example, Tomcat. Tomcat, if you install, both can be same. Similarly, let's say Node.js, right? When you run Node.js with Express.js, okay, it's actually like a web server is equal to app server. Okay. Similarly, when you run Java with Tomcat, okay, it becomes like a web server and app server because your web server, your Apache can run that Java code or the PHP code, right? So that is where the app server and web server will become same. So it's not that you need always both, right? Or both the softwares installed. You can have just one software. With that, you can run multiple things also. Okay. But based on the complexity of your application, you can divide. Some applications will divide it so that because it's more complex and they don't want to use the resources required for static delivery and dynamic delivery from the same software, right? So that's why they divide the app server and web server. So, like, is the doubt clear? What's app server and web server?
Yes, sir. Thank you.
Yes, sure, sure. And please ask questions, okay? They're really good because maybe I would have not explained what's an app server. That's a good question, okay? That's why even others got to know that, okay? So please ask the doubts. Okay, right. So let's now move on to next topic. Coming back to on-premise and cloud, okay? So now, if you see whether it's on-premise or cloud, things are same. Now, how will you choose between on-premise or cloud? Like, let's say I am building an application, or I am like creating some Amazon.com application. Okay, so will I design it for on-premise or cloud? How will I decide? So it's simple. Okay, in on-premise, what happens now? Let's say I'm building something on-premise. Now, when I'm building something on-premise, let's say I need 10 CPUs. Okay, and let's say I need a 10 TB storage, or I'll just keep 1 TB. Okay, I need 1 TB storage. So let's say a CPU cost around, let's say 25,000. So around, or I'll say 50,000. So I will just spend 5 lakh on the 10 CPUs. So cost is 5 lakh plus, let's say, storage cost, maybe 1 TB storage. I will spend somewhere around 20K. Plus every month some Wi-Fi power and all, I will spend another 10K per month. Let's say, okay. Now, so total my yearly total cost that I have to spend upfront, like when I'm setting it up, right, is around 5 lakh, let's say 30,000. Okay. Now, when I come to cloud, okay, cloud, what happens, right? You pay per hour. So how much you buy, you pay per hour. Okay. So in cloud, the thing will be, let's say, if 50,000, I mean, the cost of the cloud will be almost like maybe some $1 per hour or in that range. Okay. So let's say per month, my total cost might come to around, let's say, maybe 25K or maybe 30K per month for 10 CPUs, I'm saying. Okay. For 10 CPUs, I'll have to pay, let's say 30 or even 50K. Plus, like let's say something like generally everything will be included in that per hour cost, and maybe some IP you're buying, everything, whatever single things you buy also you will have to pay. Okay, so everything. So let's say another 10K for other miscellaneous things. So total comes to 60K. So by seeing this, which one is profitable? Now, when will this become profitable and when will this become profitable?
Sir, if it's short term, then on premise is good. If it is long term, if
Opposite,
long
right?
term was on premises,
Yeah, correct. I got it. So what happens now? Let's assume I am running it for 1 year. Okay, like I need this I'm sure that for 1 year I will need 10 CPUs. That I'm sure. Okay, so this will become 60,000 into, like, let's say 12. Okay, somewhere around 7,20,000. Okay, now which is good? Now which is good? This one, on premise or cloud?
On premise.
On premise, right? Now let's say I am sure that this application will run only for 3 months. After that, that 10 CPU I'll have to close. Okay, maybe some development is happening or something is happening. It's a temporary application. It doesn't need 10 CPU always. It will come down to 3 CPU and all. So if that is the case, then what will happen? This 60K will become 180K. Now which is profitable? Cloud.
Cloud.
Right? So this is the way you need to decide between on-premise or cloud. So what you are going to invest, right? Upfront investment, how long you are going to use it, and all those, if you consider, you will get an idea whether we need to go with on-premise or cloud. Now the other things are other factors. There are other factors also. See, now let's say when I said 10 CPU, I need, okay, for serving 10,000 users in my application. Now, will my user be always 10,000?
no,
If I
it
say
will
10,000,
change.
it will change. It
It will.
might come from 100 to 10,000, right? Somewhere in that range, it will fluctuate, right? So for 100, I don't need 10 CPU, right? But for 10,000, I need 10 CPU. For 100, maybe I need only one CPU. For 10,000, 10 CPU. So on an average, let's say 80% of the time in the whole year, okay, 80% of the time, let's say the user count is always 1,000, or maybe let's say 4,000. So I need 4 CPUs, let's say. Okay. Now, if I have already bought 10 CPUs, what will happen to that extra 6 CPUs? What will happen? Because I'm using only 4 CPUs 80% of the year. That means almost 300 340 or 330 days. I'm using only 4 CPUs. Rest of the 6 CPU is coming into picture only during those next some 30 days, like some Christmas or some festival time when the users are more. So rest of the time only 4 CPUs. So how much did I spend? Let's say I spend some 100K. Okay. Out of that, 60K is waste for 330 days. Are you getting the problem, all of you? Are you getting what I'm trying to say here?
Yeah, yes,
Yes.
sir.
Yes.
Right. So in this case, what is a good solution?
Cloud is the best solution.
Exactly. Right. When your user load is fluctuating, okay, and you see that you don't need that high number of CPUs always. Okay. In that cases, you need to go with cloud because cloud has various other good service or solutions also. Like for this case that I said, it's auto scaling, right? Now in auto scaling, what auto scaling will do is it will, based on the user's load, it will add one CPU to 10 CPU and accordingly it will manage the CPU count and you pay for what you use, right? If it is one CPU, you pay for that, 10 CPU, you pay for that per hour, right? So that way you will be able to optimize your cost to almost 40%. So that situations cloud is good. But yes, let's say you have a banking or admin application where you know that always it will be 100 user. Then there is no use of going to cloud because then cloud becomes costly in a long run. So now if someone says to you, choose between on-premise and cloud, can you do that easily based on the application?
Yes.
Now the next question. Now, if this same question I had asked you before half an hour, is there any change in the thought process?
Yes.
Okay, so can someone say one example, like what was before and now? What you thought before and what you know that, okay, this is how it's done. Anyone? Any doubt? Which got cleared? Let it be very stupid also, okay, because I am the most stupidest guy here. Okay, I'm just here to teach you. Okay, so I'm just trying to learn things from you. Okay, so please be free that like just you can speak to me like your friend. Okay, so please go ahead. Yeah.
So what is the question, sir, exactly you're asking?
Yeah. So my question is simple. Half an hour before you thought something or you were thinking something till that point of time, and now you are clear about that from on-premise cloud. Any one example like that, what you can call out, or something that triggered. Okay, yeah, this is something new. What was that?
Yeah.
So now
Uh,
I have idea, okay, on-prem and
Yeah.
cloud and that. But the thing is, still I have a question, okay. Say
Yeah.
for example, a cloud, we have the auto scaling component, right?
Yeah.
Okay. So if auto scaling, if you want to set up all the things and all, it will be high cost.
Cost in terms of what? Technical cost, right? See, when you are
Technical
setting
and
it up,
budget also.
yeah, correct.
Budget.
But again, if it's a long run, see, for example, setting up an auto scaling for a 100 CPU system, okay, and a 10 CPU system, both are different, because if you set it up for the 10 CPU system, what will happen is you're unnecessarily doing it, because maybe the cost of implementation is too high compared to the cost that you might pay, right? But let's say if you're setting it up for a 100 CPU or 200 CPU system, the cost of implementation will be just 2% of what you will save out of it. So that way you need to optimize.
Okay.
Yeah. Okay. And
Okay.
auto
Okay.
scaling as such is a free service of AWS. I mean, like you don't pay anything, There are some Lambda service and all that you use. For that you might pay, but auto scaling itself, Amazon doesn't charge anything because they get money from the extra CPUs that you use, right? So that is the way they earn. Okay.
Okay. So now what I understood is if in the future or going forward, if the number of users are increasing,
Mm-hmm.
then we are going for cloud is the best option.
Correct. Yes, you can say that. So if you feel that the number of users might increase in future, we don't know that clarity, or we don't know
Hmm.
that surety, this much will be the user count or the load, then cloud is a good solution. Exactly. Yes.
Okay.
Yeah. Yeah. Manikant, please go ahead. You had a point, right?
Yeah,
Yeah.
yeah. Earlier, I used to think that on-premises bit is used for only for the banking domains or
Mm-hmm.
some other where we can they
Yeah.
has to
Mm.
secure their data. So
Yeah.
they will build their only on-premises servers. If any other e-commerce or anything, they usually go
Mm-hmm.
with the cloud. So I thought in that process, but you have given some extraordinary
Yeah.
clarification for that.
Yeah, that's good. So yeah, when you said that, let me give you one more example. Okay, there is one I work for. I'm like a very big fast food chain. I will say the top. Okay,
Okay,
number one of the world, and they had a customer service. I mean like a customer portal. Okay, which is on premise.
okay.
So customer portal means what they do is they store all the customer data.
Mm-hmm.
Customer data means like the username, password, then the mobile number, contact, address, the loyalty point. I mean, like the points and all, right? Everything on that one customer. We call it the DC. We used to call it DCP, customer portal. So there they used to save this data. Now, can someone say why they made this on premise? Why they're
Yeah,
storing the customer data on premise?
privacy or security, data violation or
Exactly.
something.
Exactly, right? Because if you put it on cloud, what will happen?
May
Though
stolen.
AWS, yeah, AWS says we don't look into it, or we don't, your data is safe. But in case something happens, okay, so especially if it's such a big fast food giant of the global giant, okay, and if their data gets stolen, millions of users are using it, okay, they sell more than 10,000 burgers minute, right? So such is the huge volume that they're working with. So when that data gets leaked or something, maybe that time AWS might say, okay, it was some technical glitch or whatever, but their data is gone, right? And their business will be like in dust sometimes. Maybe anything can happen. So that data privacy, data retention, data storage, where the data becomes very critical, right? Or it has to be secure. We have to go with on-premise. This is also one important point. So there you don't see the cost. Okay, there the more weightage is given to the customer data or that secured data. That's why banking applications generally you will see on premise only, but they will have
So
some applications. Yeah, please go ahead.
that means cloud is not secure, sir, much.
So actually, it's like Facebook. Okay, when Facebook says your data is secure, it is secure, but it's on someone else's system. No, still it's not in your system. Are you getting my
Mm,
point? Right?
yeah, yeah,
Yeah.
got it, sir.
So
Okay.
cloud says it is secure, but we cannot be sure, right? Because it's on someone else. You are storing that data on someone else's CPU. It's like, okay, let's say your laptop is with me, okay, and you are storing the data with me, and I say to you, your data is safe. I'm not opening your laptop. I don't know your password. Are you getting, Nag?
Yeah,
But
correct,
still
sir.
you
Got it.
might, but still you might doubt, right? Oh no, something, maybe sir might have some some software to run, and he will run the, so something like that, right? Are you getting my point, right?
Yeah, yeah, correct, sir.
Yeah, yes, yeah. So that's the thing. Okay, so cloud is more about that privacy security. When it comes into picture, cloud becomes little, people don't use it. But but if you see, this is only a small chunk of part, right? The where the data has to be secure, but there will be a lot of other 80% things where the data has not, like, it's not I'm like, you should not be that careful. So that 80% things you can move on to cloud always and you can save a lot of money, okay, by doing that. So that's the thing. People use hybrid, some on-premise, some cloud. So even like the fast food giant, which I said, they had the customer thing on-premise. They had their application, the mobile app in which the ordering happens, right, and the websites and all on AWS, right? And yeah, and they used to pay a huge amount of money to AWS. Like if I remember, it was 1,000+ crores per year they used to pay to AWS, okay, for the infrastructure that they were providing. And they had a they were using other services also, because what happens with cloud, no, you get some other uh, proprietary services of AWS, like this SNS, SQS, then they have this their various ETL, DynamoDB, and all those which are proprietary to AWS, right? But same thing you'll find in Azure also with some another name. Okay, same thing you'll find in Google Cloud also with some other name, because they are all competing with each other, right? SNS is a notification service, SQS is a queuing service, then ETL is like extract, transform, load. So the DynamoDB is a proprietary DB by AWS. Okay, so they have an SLA of 2 milliseconds. So they say that any DB query will run in under 2 milliseconds if you use DynamoDB. Okay, so something like that. So they have their services. So for that also, some people opt cloud to get these services as an add-on, right? So yeah, nowadays AI is there. So AWS, you would have heard this BlackRock and all, right? Uh, AWS SageMaker and all. So they are for, and Azure we have AI Foundry. So they are all competing head to head, right? So to get the customer, so they keep releasing different add-ons also, which people can use, right, to improve their applications. So that's all the story about on cloud and sorry, on-premise and cloud. Any final questions from these?
How could they configure the hybrid for some for some APIs for cloud, some for on premises? Is
Exactly,
past.
right? So you only said your answer, API,
Okay.
right? Ultimately, if you have an API is a universal thing, right? It is
Yeah.
communicating with
Right.
anything. It doesn't matter it's whether it's on premise or cloud. If you have an API, that's done. You can communicate.
Okay. Got it.
Right?
Thank you.
Yeah. Yeah. We'll discuss more on this. This API is a very beautiful concept, okay? That I will explain when we go to this microservices and all. And that time you will understand how API revolutionized the software development overall, right? The speed, the scale, and the the power with which the agile is moving now, right? Is, I will say, API is the booster for that. Okay, so it is a revolution. So we will see that. Okay, how API is so important and how it makes life of developers so simple, but at the same time, life of testers very miserable. So, anyways, yeah. Okay. So, any doubts, anyone? So, Kiran, Manikant, Sreyasi, Purnima, just raise your hands if everyone is clear. Okay. Parimala, Giri, Nag, Sai, Arjun, Mahesh, Jyoti, PK, Garima, Sudhakar, Pratnya, Ashwini, so many are there. So I don't see any hands till now. No hands. So not anything is not clear. Okay. If all of you are clear till whatever I have taken, just raise your hands. That's the thing. Okay. I can see 6 hands. That's good. 7. Awesome. 8, 10, 12, 13. Okay. Awesome. Good. So yeah, I'm happy that most of you are clear with these concepts. But see, now these concepts are really very important. Okay. Now someone might ask me as a performance tester how this will come directly. Maybe it will not come directly to you at the initial point of time itself, but this will be very important when you are in a meeting or a call, when you're speaking with an architect or a developer. When they use these words, when they share you some materials, architecture diagrams, and all, so that with that you can understand what you are going to test the application. So these things are very important for you to understand those technical things, right? That time you cannot like with a 5 years experience or 6 years experience, you cannot go and ask them, sir, what is a web server? what is this symbol, what you are drawn web server, I'm not understanding, or it will look very childish, right? So we have to be very careful with the, at least those basics we need to know what we are doing now, right? That is what we are covering now here, so that you don't feel, I mean, like, you feel confident to speak to developers, architects, right? When you speak, and when you do that, your visibility also increases. So these are the concepts that will improve your visibility as a technical expert, okay? And maybe move on to the next phases of like a test architect or a technical architect, right? This will help you, not just testing, okay? Okay, right.
Sir,
Yeah.
do we have the previous class sessions, sir? I am just missed out those sessions,
Yes, yes,
recording
we
sessions.
have the recordings. Yes, you will get the link, which will have the playlist of today's video. No, we'll have the other videos also. You can just click on that
Okay,
link.
okay. Thank you, sir.
Okay, yeah, sure. Okay, right. So we are almost at the. So we know now what is on premise, on cloud. Okay. Now let me move on to the next concept of. Today, I think I won't be able to cover all, but still I'll pick up. So I want to cover CDN. I want to cover what is a load balancer, what's a middleware, and what is SSL basically. Okay, what is that security layer we speak about? What's that SSL or encryption? I can say. What do we mean by encryption, decryption, and all, right? So that we will see. And fifth, let's say, before we move on to JMeter again, cookies and cache. This is very, very important. Okay, as a performance tester, if you don't know this, there is an incident where one of my juniors lost his job due to a small blunder he did without knowing the cache. Okay, that incident also I will clearly with the case. Okay, I will explain when we go to that cache. So this cookies and caching is very, very important. Okay, as a especially as a performance tester, that I will explain. Okay, now let me start with CDN. Or let me start with the easiest one, since we have only 5-10 minutes. Middleware. Okay, so see, generally how an architecture of an application will look like, right? So let's say I will just draw it from the back. Okay, I will have the DB, which is the most starting layer, I can say, most of the time, DB server. Okay, then I will have the, let's say, the web server or app server, whatever. Then this is one optional component, right, which is called the middleware. And here, after the middleware and between the web server and app server, you will have the load balancer. And here you will have the CDN, and then you have your browser where you browse, right? Simple. So this is how the layer by layer your request will go. For example, let's say I hit Amazon.com. So first Amazon.com will go, enter through the middleware, go through load balancer, and from load balancer it will enter into the proper CPU, whichever where it needs to go. It gets processed, pick something if something is required from DB, then travels back, travels back, travels back, travels back, picks few things from the CDN, and then shows it to you in the browser. So this is how the overall communication happens, cyclic. Okay, layer by layer. So middleware is something somewhere here. Now middleware is a component. There are various different companies that give middleware. One famous out of that is MuleSoft. They provide that middleware software. Okay, so this middleware is basically, it's more sort of like a security layer before entering the backend. So this security layer, what it does is it will check if the request coming is a proper request. Is it coming from a valid source? Is there any problem in the request? Even sometimes it will make sure that the request will not fail. Okay, if something that, like for example, a backend is not ready or something, it will throttle or it will wait for that to happen and then send the request. All those things the middleware will do. So middleware is mainly a security layer, we can say, before entering the backend. And once it leaves the middleware, load balancer will route it to that CPUs. That we will see when we see the load balancer in detail. Okay, what is load balancer? So middleware is a security layer generally between the backend and the world, right? Before anything enters the backend, middleware will make sure it filters out the proper requests without any issues. Okay, that's a middleware. Now tomorrow, I will not go further today because it's almost 9:55. Okay, let's see load balancing quickly. Okay. Okay, so let's assume I have an application, and that application has 4 CPUs. Okay, CPU 1, CPU 2, CPU 3, CPU 4, and all these 4 are connected to the same disk in which the data is stored in. So, in a way, CPU plus disk is a system, you can say, right? CPU means there is CPU and RAM. Okay, both. When I say CPU, actually, if we go to cloud, we say nodes. Okay, node 1, node 2, node 3, node 4, instance 1, instance 2, instance 3, instance 4, right? But I'm not using that word now. Purposefully, I'm using CPU because once you learn node and instance, I will use that word. Okay. Now, so my application code is stored on the disk, right? The code, the files, and everything is on the disk. CPU is for processing, right? Processing, running the code and all. So even the server, the web server, the app server, is everything is running on this CPU, right? So my question is web server running on all 4 CPUs for my application?
Yes.
Exactly, right? My web server is running on all 4 CPUs. Even if application server is there, it will run. Even DB server is there, that will also run on all the 4 CPUs. Okay. Now, let's say I am sending a request. I send Amazon.com. Okay. Let's say get Amazon.com. I send a request. What load balancer will do? It will check. Okay, CPU 1 is at 70% capacity. CPU 2 is at 70% capacity. CPU 3 is at 70% capacity. CPU 4 is at 50% capacity. So what it will do? It will send this request to CPU 4 because it is at 50% capacity. It can go further to reach 70 so that others are not overloaded. Similarly, let's say thousands of requests are coming. It will do this same thing, okay, for all those thousands. So this is a load balancer. What it does is it will distribute the load among the CPUs to process it properly so that no single CPU crashes. Now see, now here it's not at always equal. Even you can distribute the load unequally also. For example, if we, like let's say I said this is 80%, this is 80%, this is 50%, 50%. Okay, so what I say to what I can configure my load balancer is this for this 80% should be the max. For this one, let's say 50% should be the max. So that way also, like in a ratio, not only equal, like equally, but let's say this can take twice, this can take once, this can take thrice, this can take. So that also I can do in a ratio. Okay, the number of requests. So 2 requests will go here, 1 will go here, 4 will go here, 5 will come here. So something like that. That also load balancer can do. Now my question is, what is a load balancer? It is also a software. It's a software running in a CPU, running in a system. So load balancers are 2 types, okay? Digital and analog. So this software that is running is called digital, okay? So digital load balancer is where a software runs in a CPU to distribute the load. Analog actually is little like obsolete now. Okay, people are not using it. But analog is mainly like what it used to do, right? It had physical switches and all. So this switch will on, it will go to this CPU. This switch will on automatically. It will go to this CPU. So that the way it used to handle. Physical switches used to be there, which used to be automatically controlled based on the load, right? Analog digital load balancers were that, but digital is now almost 99%. Okay, so analog people are using only for very, 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 mission critical, or I can say very very rare cases. Okay, right. So that is a load balancer. So from the name itself, load balancer balances the load among all the systems, right? So that it doesn't crash. Now my question to all of you, as a performance tester, is load balancer very important or not?
Very
Yes,
important.
it's important.
Very, very important, because leave the concept of load balancer. In its name itself, there is load. so we have to be very much we should show the affinity towards load balancer. So always when we test, we have to surely monitor the load balancer. Okay, first, that is the first important thing which we need to do, because if your load balancer doesn't perform well, or if there is any problem in your configuration or anything goes wrong with the load balancer, your CPUs will crash, because one CPU will get overloaded, others will be underutilized, and that's one way of seeing it. Multiple different problems will come if like let's say if your CPUs are all utilized, it will add more CPUs due to auto scaling, right? That also will happen, which is actually not correct, because maybe all CPUs are not utilized properly, right? So such things, many things can go wrong due to load balancer. So load balancer is a very important component for a performance tester, which you should never ignore, and you can easily monitor the load balancer load on AppD and Grafana. Okay, so you can monitor, like for example, let's say I'm monitoring the load on load balancer. Okay, and I'm monitoring at the same time the load on all the 4 CPUs. So I should see the same behavior that I have configured in both. Are you getting, all of you? Are you getting
Yes.
what I'm trying to say? So that is how you find out whether there is any problem in the load balancer or not. And the other thing is, when I'm running the test, if I get a graph like this, the number of the load graph, okay, if I get like this, then there is something very critical issue with the, I will not say only load balancer, but could be load balancer, because my load is like it's fluctuating a lot, right? Are you seeing? It's like the load is fluctuating a lot, and which is also could be a indicator that your load balancer is not performing well. Okay, yeah, anyway, so all these things we will see in the further sessions too. So yeah, now I can take some questions, okay, before I close today's session.
Whether load balancer will be configured on the on top of the infrastructure web servers and the
Yeah,
load.
generally we will run it on a different instance. I mean, like a CPU. We
This
will
will be in the
run a CPU,
network.
correct, and yeah, in the network, yes, in AWS or wherever it is,
Okay.
in the cloud. Even you can run other softwares also onto that CPU. Okay, it's not that only load balancer can run inside a CPU. You can run some I will not say application related softwares, but if some other services you need to run, okay, which doesn't need to run on the backend server, right? So you can utilize, but generally load balancer will be kept separate, okay, so that it has the full resource to perform well.
Okay.
Yeah. Any other doubts, anyone?
Then what is the use of here, the middleware server, sir? I mean,
Middleware
see,
is a
as you told,
security, like it's a security gate. Okay, so it's
okay,
like a person who will not leave everyone. Okay, but it will leave people who have proper request. I mean, like proper. It is coming from a proper source. It has a proper body. It has a proper even token and all, right? Proper authentication token. It will leave those requests further for processing. It's like a filter layer or a security layer. Middleware.
mhm.
It plays only role during entry, not the exit, right?
No,
Middleware.
no, no, not
Okay.
no. Exit it will not. Yes.
Vishnu,
Yeah.
if uh, if interviewer asks, can you please explain your application architecture and what
Mhm.
should we tell and what are the things we have to mention?
That's a good question. Okay, so that's why I drew this diagram. Okay, So when your interviewer asks that, start from this browser, okay, and go left to right. Explain all these components one by one.
Okay. So
Yeah.
we have used three-tier architecture, and these are the things we have like that we have
Correct.
to tell.
So we have a CDN, we had a middleware, and middleware was this. CDN was provided by Akamai, because every component here, right, has one provider also. So CDN is provided by Akamai. They are a leading provider. Middleware MuleSoft. So you can just remember those names also. Who was the provider, right? Akamai, and middleware was MuleSoft. And load balancer, we had a digital load balancer which used to distribute the load among the instances that we had in the backend. And this is all backend. So the backend, then you can say in each server, we had a web server and a DB server, which used to pull the data, process it, and further send it to the browser.
So those things will be provided by the cloud.
Which one? Shreyasi?
These load balancer and
Yes. So yes, your cloud will provide you. Even on premise also, you can set it up. It's a software.
okay.
You can download open source. Yeah.
Okay. Yeah.
There are open source softwares available which will act like a load balancer, but cloud has their inbuilt functionalities also. I mean, like you can easily set up load balancing in cloud, because for auto scaling and all, they need a load balancer, because load balancer will monitor the load and scale your CPU, no? So yeah, so load balancer is compulsory when you have auto scaling setup.
So you will be going to show us in the project or something?
Yes, yeah, I will show you. I will show you how the auto scaling happens, and what is like how the load balancing happens. Okay, maybe I'll not install. I mean, like I will not be showing you how to install and all, because it's already installed. When you set up a Kubernetes cluster, right? It will come in inbuilt inside Kubernetes.
Okay.
Yeah. Any other
Sir,
doubts?
what is the use of that component, sir? That CDN component. So
Yeah, we
first
will see that. Yeah, that we will see tomorrow. Okay. Yeah.
Okay. Before middleware, say it is
Correct. CDN.
CDN,
Yes.
right? Okay.
It's called content delivery network. We will see that. Okay. Yeah.
Thank you, Vishnu.
Sure. Yeah. Then yeah. Any other doubt? Kiran, you had some doubt?
Yeah. You were saying that middleware acts like a security layer for all the applications, right?
Yes.
So nowadays, so many applications are getting hacked. So it means that those people are not using the middleware, or if they are using middleware also, they are hacking that?
We can't say that, because see, middleware, when I say security, it's not only it's not that. Yeah, one important thing, middleware is not compulsory. Okay, it's optional. So some people will not use it, exactly, because you have to pay for that, no? But the main thing is, see, middleware is some security issues even middleware cannot catch sometimes, if it is your code vulnerability. So middleware can catch only those issues which you configure. I mean, like, let's say you configure that in header this should come. If it doesn't come, middleware will fail it. Okay, but if your configuration itself is not correct, then that security vulnerability will penetrate. Right?
Okay.
Yeah. So middleware, again, one thing is middleware is optional. It has a cost, right? So everyone will not have middleware, but even middleware is there also, security layer penetration might happen due to the code vulnerabilities. So that's why security testing is done separately.
Yeah. Okay.
Yeah.
Vishnu, generally, what type of algorithm will be used in real-time applications, like load balancer, like round robin, or some other?
Equal, right? Like they will distribute equally among all the CPUs. Yeah. Okay then. So what I feel is, okay, let's stop it here for today, and we will continue tomorrow. Thank you all. Have a good day. Good night. We'll connect. Thank you. And thank you for joining the session. Thank you.
Thank you.
Thank you.
Thank you all. Good night.
Thank you.